So in this discussion, we have to arrive the probability density in Dirac's field. For that, we have taken the Dirac's Hamiltonian H equal to E equal to C alpha dot P plus beta MC square. Then equation 1 is allowed to operate on the wave function psi. We can get E psi equal to C alpha dot P psi plus beta MC square into psi. Here the E is replaced by energy operator IH cross dou by dou t, and then P is replaced by the momentum operator minus IH cross delta. Therefore, we can get the equation of form 3. Now we have to take the Hermitian conjugate of equation 3. If you take the Hermitian conjugate to the above equation 3, this IH cross dou psi by dou t is changed as minus IH cross dou psi dagger by dou t. Then this IH cross with a negative sign is changed as plus IH cross. Here alpha dot del psi is changed as del psi dagger dot alpha because we are taking Hermitian conjugate. Then this beta MC square into psi is changed as psi dagger beta MC square. Now pre-multiply all the terms of equation 3 by psi dagger. We can get IH cross psi dagger dou psi by dou t is equal to minus IH cross C psi dagger alpha dot del psi plus psi dagger beta MC square into psi. Now consider equation 4. We have to multiply all the terms of equation 4 by psi on right. You can get minus IH cross dou psi dagger by dou t into psi is equal to IH cross C del psi dagger dot alpha psi plus psi dagger beta MC square into psi. Now we have to find the value of 5 minus 6. Just take this first term IH cross psi dagger dou psi by dou t minus of this term, so minus to minus plus, so plus IH cross dou psi dagger by dou t into psi. If you come to the right hand side, the first term is present as such minus IH cross C psi dagger alpha dot del psi minus of this term IH cross C del psi dagger dot alpha psi. These two terms are cancelled out. Now we have to modify this left hand side by the way of taking out IH cross. If you take IH cross outside, the rest of the terms are psi dagger dou psi by dou t plus psi into dou psi dagger by dou t. Here I have taken out minus IH cross C outside as a common term. Then the rest of the terms are psi dagger alpha dot del psi. This minus is changed as plus because we have taken out minus IH cross C outside. So plus del psi dagger dot alpha psi. Then bring all the terms to the left hand side. So entire is equal to 0. Now we have to modify this using d by dt of uv, so that the terms available inside the bracket is dou by dou t of psi dagger psi. We have cancelled IH cross from each and every terms, so that the first term is dou by dou t of psi dagger psi. Here C into psi dagger alpha dot del psi plus psi dagger dot alpha psi. This is simplified as del dot C psi dagger alpha psi. Entire is equal to 0. Now we have to compare this equation 10 with our continuity equation dou p by dou t plus del dot j of r comma t equal to 0. From the equations 10 and 11, we can come to the conclusion that is P of r comma t is our psi dagger psi. This is probability density. Then the j of r comma t is equal to C psi dagger alpha psi, which is called as probability current density. The value of P of r comma t is equal to psi dagger psi is almost similar to the value arrived in our non-relativistic case. In the case of non-relativistic quantum mechanics, the probability density is psi star psi. In our Dirac space, the position probability is psi dagger psi. Then if you define the normalization condition in Dirac's space, integral psi dagger psi d tau equal to 1 is our normalization condition, whereas in our non-relativistic quantum mechanics, the normalization condition is psi star psi d tau is equal to 1. if you want to find the expectation value of an operator in Dirac's formulation, say A is an operator, we do not know the value of A, expectation of A equal to psi dagger A psi d tau divided by psi dagger psi d tau. Suppose the wave function is normalized, that means psi dagger psi d tau equal to 1, then expectation of A, which is equal to psi dagger A psi d tau. This is our expectation value of an operator. Suppose if you want to find the expectation value of energy operator, expectation of E equal to psi dagger IH cross dou by dou t, that is energy operator value psi into d tau whole divided by psi dagger psi d tau. If the wave function is normalized, the expectation of E equal to psi dagger IH cross dou by dou t psi into d tau. So in this way we can express the expectation value of an operator in Dirac space. Thank you.